start recording. Okay, folks, welcome back. We're going to talk about chapter 13 now for the brain. So we're going to go over some of the basic anatomy of the brain. And so some of the stuff I kind of reviewed in lab. You had a question, Anna? This is for the next test. That's right. Yep. So a couple basic structures and concepts that I want to jump into first. First, I was kind of hammering this home in lab. There's 4 regions to the brain. Okay? I don't want you to confuse regions or lobes. Completely different. Okay? So there's 4 regions. Okay? Cerebrum, diencephalon, brainstem, and the cerebellum. We're going to go, for this chapter, we're going to go through each one of those regions. Okay? So when you're looking at the brain, I'm going to come back to this slide, you'll notice that you have all these different folds here. Okay? And then in between the folds, you have these little depressions. In some areas, you have bigger depressions. Okay? So there's a name that we give the folds, all right? We call those gyri. Or if you're talking about one individual one, it's a gyrus. Okay? Gyri is the plural. And then those depressions that you see, okay, we call that a sulcus or sulci, plural. If it's a deep depression, then we refer to that as a fissure. Okay? So there's a couple other anatomical terms that I need to throw in here. I don't use them that often, but you should know them regardless. Rostral and caudal. A lot of that comes from embryology and just the position of the brain and whatnot. So if you hear me say rostral, I'm referring to the anterior portion of the brain. Okay? Caudal will be the posterior portion. Okay? I don't use those too much. Someone left their water bottle in here and I keep reaching to drink out of it. I don't want to be messing with that. It's been sitting here for a few days, so. Ain't nobody want to drink out of that. Okay. So, again, we've already went over this in lab. Okay, so you're going to be somewhat familiar. All right, here's your central sulcus here. Okay, this nice depression in here. Okay, we've got our anterior lobe. I'll jump into that. I'm jumping ahead. Okay, so back here, or actually in the front here, this is going to be the anterior rostral portion. Back here is the posterior caudal portion. Okay, you can see the 4 regions. You've got your cerebrum, then you got your cerebellum, little mini brain here, and then part of your brainstem. The 4th region's in the inside here. We can't see that. That's the diencephalon. So now let's look at the inferior view of the brain. And you're going to get to know this quite a bit here because you can see you have all these nerves coming off. So what do we call a nerve that comes off the brain? What do we call a nerve that comes off the spine? Off the spinal cord? Spinal nerve. So what do we call a nerve that comes off the brain? Cranial nerve. Yeah, perfect. Good. Okay, that's good. So we're going to learn all these different cranial nerves, and that's what this is showing you here, different structures. Okay, so this is an inferior view, and then we're going to do a mid-sagittal view where we cut the brain in half. Now we can actually see the diencephalon. All right, that structure right in there, that's the diencephalon. Okay, and there's 4 parts to it, or excuse me, 3 parts. Okay, you got your thalamus, your epithalamus, all right, and then your hypothalamus. And we're going to go through all those different parts there. Okay? Let's start off with the first region of the brain, cerebrum. Okay? So this is where your higher order brain functioning, or what we call complex intellectual functions, occur. Okay? So your deep thinking, philosophizing, all right, pondering, whatever you want to call it. Okay? So that's where we're going to find these functions are going to occur here in the cerebrum. Your cerebrum has 2 halves or hemispheres. You have your right cerebral hemisphere and your left cerebral hemisphere. Okay? So keep in mind, all right, all these different functions that you'll see there. Okay? What you're doing right now, right, intelligence and reasoning, as you're sitting there thinking over this material, trying to learn it as I am talking to you, right? All those functions are occurring here in the cerebrum. Okay? Short-term, long-term memory, judgment. So you think that some people don't have a very big cerebrum, they're using poor judgment, but it's there. All right? Conscious thought occurs here. And then we're going to talk a lot about voluntary motor, visual, and auditory activities. So a lot occurs in the cerebrum here, okay? So let's jump in here into the cerebral hemispheres. Your cerebral hemispheres, all right, are divided by this structure here, which we already talked about, a longitudinal fissure, okay? So that's what keeps your left and right cerebral hemispheres separated from one another, okay? But not to worry, because your hemispheres can communicate with one another, okay? Now, just to kind of review, all right, I talked about the peripheral nervous system. We call a bundle of axons, parallel axons in the peripheral nervous system, call those a nerve, okay? Well, a bundle of parallel axons in the central nervous system is a tract, okay? We call it something different in the central nervous system. So when you see this term tract, right, think of it as, I don't want you to think of it the same thing as a nerve, all right, that in the peripheral nervous system. It's very similar. Okay? It'll both have motor and sensory functions. Okay? So it is made up of white matter. Now, what is white matter? I really haven't focused on that. White matter is myelinated nervous tissue. Where is myelin on a neuron? Where do we see it? What part of the neuron? The axon. That's right. Absolutely. That's the only place. So if you see white matter, okay, the only part of the neuron that's going to be where white matter is in existence, all right, for the most part, is going to be the axon, okay, because myelin doesn't go on the cell body, doesn't go on the dendrites, doesn't go on the synaptic knob. Myelin is only present on the axon, okay? So keep that in mind. So when you hear me say white matter, you're thinking, all right, well, if we're in the brain, the spinal cord, it's a tract, okay? And it's a myelinated axon, okay? Anyways, these tracts that connect the hemispheres to one another, we call those commissural tracts, okay? But specifically, the one that we learned in lab, the largest one is the corpus callosum, okay? So this is what allows the right and left hemispheres to communicate with one another, okay? Certain parts of our cerebral hemisphere will undergo certain functions, all right? So it might vary from individual to individual, okay? Now what I mean by that is, okay, now for the most part, vision occurs in the occipital lobe for every single one of us, okay? Our ability to speak, okay, all right, is going to occur in my frontal lobe and parietal lobe, okay? Well, I'll get into that, okay? We know that that's specific, but it might not be it. If I were to measure it specifically with a ruler, right, where it might be specifically in me, it could be a few millimeters off in you. Okay, so I mean, we know where it is in general. It's not going to be the same, right, for every individual. That's what I'm kind of explaining to you. Okay, so keep in mind that most of the functions in our body are crossed. Meaning, for example, right, the right side of my cerebrum is going to control the motor function in the left side of my body, and vice versa. Okay, so that's what this statement says here. Connections with the body are generally crossed. Okay, so the example here is the left hemisphere is going to receive sensory input from the right side of your body. Okay, so if you touch something with your right hand, you feel that it's hard, right? That information is actually winding up on the left side of your cerebrum. Okay, and we'll find out exactly where that is. Okay, all right. So that left cerebrum, then, right? If you want to move your right hand, okay, left cerebrum is going to send the motor signals to the right side of the body there. Right. So this term here, lateralization, we're going to talk about that. When we talk about higher order functions, those are the more complex functions. Right? But usually one side of the brain is responsible for certain higher order functions, which we refer to as lateralization. Okay? Like I was mentioning before, speech. Okay? For most of us, that's going to be on the left side of your brain. Okay? Now there is some situations and some rare individuals in which it's on the right side of the brain. Okay? But for the most part, it'll be on the left side of the brain. Right. So when we're looking here, There's a ton of psych studies on the. Oh yeah, well, and in some cases they've had to sever certain parts of the corpus callosum to prevent certain epilepsy. Okay, they've had to sever certain commissural tracts. Now you have the anterior commissural tract, you've got a posterior commissural tract, which are much smaller, but they've had to sever. Yeah, that's funny you say that. Some of that has been utilized with epilepsy. We'll talk about that actually. All right, so looking here on our picture, all right, you got your frontal, parietal, and occipital lobes here. Okay, so keep in mind, right, that certain sides of the brain, okay, left hemisphere or right hemisphere, but like I said, with speech, right, it's a higher order function, right, is going to affect, all right, not the opposite side of the body, but your speech will be found on your left hemisphere. Okay, just to kind of review. Let's talk about the lobes. Okay, so now we're going to focus. Now you guys already know at least where 4 of the lobes are located because you know where the cranial bones are. Okay, so the lobes are named for the cranial bones in which they sit underneath. Okay, so the 4 lobes that you're familiar with already are the frontal, parietal, and temporal. And then I call it the invisible lobe, right, or the inside lobe. That's the insula. You can't see that when you're looking at the brain exteriorly. You actually have to pry apart the temporal and the frontal lobe. It's tucked away inside. Okay? Let's start off with the frontal lobe. Okay? That is going to be on the most anterior portion here. All right, the most anterior portion of the cerebrum. Okay? And there's the sulcus here that's called the central sulcus. Okay, so the central sulcus, it demarcates, right, where the frontal lobe ends. So anything anterior or rostral to the central sulcus is going to be the frontal lobe. Okay? So remember when we were labeling the brain? We had the central sulcus and we found that one gyrus there, that one fold that was immediately in front of the central sulcus. That would be this guy right here. Okay? This guy right here, that is called the precentral gyrus. It's in the frontal lobe, but physiologically or functionally, it's known as the primary motor cortex. You know, I mentioned that when we were labeling. Okay, so that is going to control voluntary movement. Okay, so if you scratch your head, if you're writing notes right now, if you're tapping your foot. Okay, all that comes from the frontal lobe, specifically, all right, that precentral gyrus there. Okay, also known as the primary motor cortex. Okay, then we've got the lateral sulcus. We also learned of that as the lateral fissure. Okay, that is going to be the bottom portion, the most inferior portion of where the frontal lobe is found. And that's what separates the frontal and the temporal lobe. Again, if we pry those 2 lobes apart and we peer into the lateral sulcus, that's where we'll see the insula. It lies deep in there. Okay. Important that you know this. Make sure you memorize this. Okay. The functions of the frontal lobe: motor control, which we already talked about, concentration, verbal communication, decision making, judgment, planning, personality. Okay, so a lot of your higher order intellectual functions occur in the frontal lobe. So far? Again, we're not going to be going too crazy today. I know you guys got a test. Have you all taken the test yet? And I know you have. Oh, wow, okay. Hence, that's why you guys are here. All right, fair enough. Fair enough. All right. Because I think we got, what, 9 people in attendance at home, so almost half my class is online with me right now. Not bad. Okay, so let's talk about the second lobe, the parietal lobe. Okay, so you kind of remember where the parietal bone was on the skull. Okay, that's kind of on the back side portion of your head there. Okay, so the parietal lobe is going to sit behind the central sulcus. Okay? And so that first gyrus right here, this guy right here, all right, that's the post-central gyrus. Physiologically, functionally, that is known as your somatosensory cortex. Okay? So your parietal lobe is pretty much made up, is just for sensation. Okay? So conscious sensation is going to wind up here in the post-central gyrus there. Okay? So the parietal lobe starts with that post-central gyrus that sits right behind the central sulcus. Right? And it'll extend all the way back to the occipital lobe, right, which is divided from the occipital, the parietal lobe is divided from the occipital lobe by the parietal occipital sulcus there, okay? And then if you travel down to the lateral portion of it, it'll end on the lateral sulcus, okay? Keep in mind, the parietal lobe, sensation, okay? So an easy way for me to evaluate how your somatosensory cortex is I ask you to close your eyes, open up your hand, and I could put in a commonly identifiable object into your hand, like a pencil or something, or maybe a remote control. You feel that, and you're like, oh, that sends that information up to the somatosensory cortex, okay? All right, that's another way, like if you're able to tell something's soft or rough, okay? All right, temporal lobe, okay? Again, right underneath the ear. This is going to be inferior to the lateral sulcus or lateral fissure. This is really easy. The function for the temporal lobe, one of the ways I remembered it for hearing, well, the ear is close by, okay? That's an easy one. Then smell, okay? So the temporal lobe has to do with hearing and smell, right? The final two lobes are real easy, okay? The occipital lobe is on the back portion of the cerebrum, okay, right underneath the occipital bone. It has to do with vision and also your visual memories, okay? So when you're looking at somebody and you're like, man, I recognize you, all right? Basically what you're doing is you're just having trouble recalling that visual memory, right? But when you're like, I've seen you before, you're just, all that information is stored in your occipital lobe. So just keep in mind, occipital lobe, vision, and anything related to vision, okay? And finally, the invisible lobe, the insula, okay? This is going to be when we pull apart the temporal lobe and the frontal lobe, okay? And we look deep in, all right? You will see taste, all right, and memory. Taste and memory. Good so far? Not too bad? All right, a lot different than muscles, right? Yeah, let's see. This material here doesn't get, what's the word I want to use? You don't have to like memorize all these different steps. It's just, I hate to say it, some of it's pure memorization, but I kind of like doing this chapter after doing those other two chapters because it's refreshing. Now you know, all right, this is where vision occurs, this is where memory occurs, this is where taste occurs. All right, now we're going to talk about functional areas. So certain areas of your cerebrum, okay, are going to be associated with certain functions, like I just said, okay? Memory and taste is going to be in the insula, all right? Personality, concentration, all that, thinking, thought processes is going to be in the frontal lobe. But now we're going to get a little bit more specific now, all right? We're going to associate certain functions to specific parts of certain lobes. For example, we're going to talk about the motor areas here, okay? We're going to talk about all the different parts of the cerebrum that are associated with movement, motor function, okay? So you heard me talk about the frontal lobe, okay? You had the precentral gyrus, okay? And that has to do with, also known as your primary motor cortex, okay? So that is, you need to know the name of that. How do I want to say this? You want to know anatomically what it's called, which is the precentral gyrus, right? And then its physiological function, right, or yeah, physiological function, that's the primary motor cortex. Okay, that's where voluntary movement is going to originate. Okay. All right. So, real simple. Remember what I said. Right? The right side of your brain controls the left side of your body, vice versa. So that means, all right, in this primary motor cortex, we're going to control the skeletal muscle activity on the opposite side of the body. Okay? Primary motor cortex has to deal with voluntary movement. And so with voluntary movement, right, that means the only the only muscle type that we can voluntarily control, skeletal muscle. Okay? So you already knew that. I'm just making you realize it. Okay? So a new term that I haven't really mentioned before, it's called contralaterally or contralateral. What that means is opposite side. Okay? So basically, right, the contralateral side of your brain which would be like the left side of your brain is going to control the right side of your body. That's what that means. Okay? So what we'll see is, right, at one point, these fibers from the left side of your brain have to cross over to the right side of your body. And that's going to occur, right, in either the brain stem or the spinal cord. And you need to know that. Okay? So that those fibers, those neurons, have to cross from the left side to the right side of your body, or from the right side to the left side of the body. Okay? And that's going to occur in one of two places: the brain stem or the spinal cord. Okay? We'll come back and visit that later on. All right. So anatomists, physiologists have gone through and they've mapped out your brain and your brain's image of what it thinks the body looks like. Okay? So this body region map we've called the motor homunculus. Now when you look at this thing, it's going to be kind of funky. Has anyone ever seen the motor homunculus or the sensory homunculus? All right. So it's very distorted only because the amount of real estate that your brain has invested into these certain parts of your body. Perfect example, where you have more motor control, okay? You'll have more brain real estate committed to that area, okay? So like your fingers and your hands, that you have finer motor control, will have more of the brain area, right, surface area committed to that certain region of your body. So I'll show you what I'm talking about, okay? Here's what the primary motor cortex looks like, right? So it's pretty funky here. Like your hand is going to be somewhat distorted compared to your forearm, compared to your arm, okay? Because more of your brain, right, is going to be committed to that area for those motor units. Remember we talked about a motor unit? It has to do with the motor neuron and how many muscle fibers that it innervates, okay? So certain areas where you have finer motor control, your brain has more area dedicated to it, okay? So parts of your calf and your thigh, you don't have very much. But parts of your face, all those muscles of facial expression, look at your tongue. I mean, there's quite a bit there, okay? Because of that fine motor control. Let me take a quick sip. My voice is just all raspy tonight, y'all. Okay. So that's the primary motor cortex, and this map here is the motor homunculus. Okay? All right. So sticking with the functional areas of the cerebrum here, a couple other motor areas that are worth note. Your motor speech area. That's what I'm using right now as I'm talking to you. Okay? We also call it Broca's area. Now, Broca, and there's another guy called Wernicke, right? These guys did a lot of brain mapping. Okay, so this guy Broca has named several areas of your brain, all right, with certain numbers. Okay, so just in case you're wondering who the heck Broca is, he was a gentleman or doctor that did a lot of, wow, that was weird, that did a lot of brain mapping. Okay, so the motor speech area, okay, the part that I'm using as I'm talking to you right now is going to be on the left frontal lobe. Okay, right? This is for most people. Now, there's always exceptions to the rules, okay? But so remember what I said, speech is mostly going to be found on the left side of your brain, okay? Where do you find the engine or the motor to your car, in the front or the back? Front, okay? Unless you're driving a VW Bug back in the days, but still, all right? So most of the motors are going to be in the front. So think of this for your brain. The motor stuff is going to be in the front half of your brain. The sensory stuff is going to be in the back, okay? That concept flips in the spinal cord, okay? Oh, no, wait. I take that back. It does not flip, all right? Something else flips there. All right, phew, I'm glad I caught myself on that one. All right, motor's in the front, sensory's in the back, okay? So when we're talking about the motor speech area or Broca's area, that's going to be in the left frontal lobe. All right, so that is, I'm utilizing that area, okay? Controlling my skeletal muscles, right? Controlling my breathing rate as I'm talking to you, okay? And so my Broca's area is going to be utilizing. All right, how about when I'm moving my eyes, okay? That's also going to be found here, all right, in the frontal eye field. Right? This is another area. So when you're watching something drive by you, you're tracking that, right? Again, that's going to be found here, right, on the superior surface, but of the frontal gyrus there, okay, way in the front there. Premotor, okay. So now we're going to get into memories and how you learn skilled activities. So to understand that, we'll talk about association areas here in a little bit. But for right now, let's just talk about the premotor cortex. The premotor cortex is going to be immediately adjacent to the motor cortex, the primary motor cortex. So going back to this slide here, okay. Here's your primary motor cortex here. Well, just in front of that here, that's your premotor cortex. So this is where you're going to start to store certain muscle memory skills, activities. Playing the piano, okay? Playing the guitar, doing certain refined, specific activities, okay? That information is going to be stored in that area there, okay? So that's going to be just in front of the motor cortex there, okay? So what do we learn here? Coordinated, learned, skilled activities. Playing the violin, juggling, okay? All that information is going to be in the premotor cortex, okay? Questions about motor? Okay, remember, where's the motor of a car? In front, okay? All right, staying with functional areas, let's talk about sensory areas. So we already talked about the primary somatosensory cortex, right? This is where that post-central gyrus is. Remember the parietal lobes on the posterior to the central sulcus, you have your post-central gyrus, okay? And this is where we have that somatic sensory information. Remember, somatic is conscious perception, okay? Conscious perception. So, examples, proprioception, okay? Your limb spatial awareness. Okay? Proprioception is your body's spatial awareness of where it is in relation to itself, okay? So if I'm standing in front of the class and my eyes are closed and someone came over and just lifted my sleeve up and did this, right? We have what are called mechanoreceptors, specifically proprioceptors. These proprioceptors are found all around your joints, your tendons, okay? And they're sending information up to my brain and telling my brain that my arm is being lifted, even though I can't see it, right? But it's sending all this information as the muscles change, as you're lifting my arm for me. Okay? It's bombarding my brain with that information, so I know that my arm is at 40 degrees, 60 degrees, 90 degrees. It's telling me that. That's what proprioception information is. All, no touch, and that includes light touch, deep pressure, anything, vibration, right? Anything that has to do with tactile touch, all that information, it's sent here, right? pressure, obviously pain, also known as nociception, and temperature, hot, cold, okay? So just like with the motor homunculus, we have a sensory homunculus, right? Again, it's our brain's distorted map, right, of what it is dedicated, right, to that sensory real estate for the actual brain tissue. All right, so I'm going to come back to this slide, but you can see again, okay, areas that are very sensitive, like your face, for example, we've got tons of receptors up there, right? You can see we've dedicated quite a bit of real estate, right? Hands, same thing. Not so much to like your legs and your calves and your feet here, right? And you can see tongue, right? So you can see pretty much quite a bit. If we go from the hand, including the face, down to the tongue, that's a lot of real estate that's been dedicated to touch information, proprioceptive information of those regions there, okay? All right. So just like the premotor cortex, right, we have a somatosensory association area, okay? So this area is just posterior to the postcentral gyrus, okay? It's adjacent to it, but it's just behind it, okay? So now, if I were to put, right, an object in your hand, a commonly identifiable object like a pair of scissors, okay? If I were to do that the very first time, you've never seen a pair of scissors, you wouldn't know what the heck that is. Then I do it a month later and I put those same scissors back in your hand, your somatosensory association area has that memory stored there. So it's going to access that and be like, oh, those are scissors. Okay. Now, when I put those scissors in your hand the very first time, you can be like, well, they're hard, they're cold even. All right. They're kind of smooth. Okay. That gives you that information, but you can't readily identify what the object is until you've created that memory and stored it here into the association area. Okay. All right, well, we've seen that picture. All right, a couple other sensory areas. Now this part gets kind of easy. When I say that, only because we've already talked about some of these areas here. Visual cortex. Whenever you're thinking anything to do with vision, you have to think of the occipital lobe. Okay. So the fact is, like the very first time, say you were to see a sunset, very first time, you're going to be stimulating your primary visual cortex. Right? Or if when you meet somebody, you're going to be, for the very first time, you're going to be stimulating the primary visual cortex. Now, you see that person again for a second time, now you're going to be stimulating the visual association area. Okay? This is where you store the memory of when you saw that person. Okay? Or if it's a car for the first time that you've ever seen, you're like, oh, I like that car. And then you go and learn what that car is. So when you go to the dealership, you're like, oh, I want that Lamborghini. Okay, now you know what it looks like. All right, and that's because of the visual association. Okay, similar with auditory. Right, that's found in the temporal lobe. Okay, so when you hear a song for the very first time, you're going to stimulate the primary auditory cortex. When you hear it for the second time, or third or fourth time, then you can recognize the tune. Okay, because you're retrieving those memories of those sounds there. Okay, these association areas are always going to be in close proximity to the primary whatever area, okay? If we're talking about the primary visual cortex, right, the visual association area is going to be immediately adjacent to it, okay? It's close by, okay? Now, there's going to be a couple things that we'll talk about here in a second that add to that, right? Smell, okay? Olfaction, temporary lobe, okay? Primary gustatory, that's taste, that's going to be in the insula, okay? And that's going to process that taste information there, okay? That's why my mom says try everything twice. You have to try everything twice, especially when it comes to food, okay? One, to see if you really don't like it or not, because it might have been made poorly, okay? I had a really good dinner last night, but I won't get into that. What else am I? Okay, so let's jump in here, all right, into some of the functional brain regions here when we're talking about accessing multiple association areas here. Okay, so now we have several different areas that are located throughout your cerebrum. And we're going to access some of those areas there. Okay? So for example, in the prefrontal cortex, okay, this is where you have your higher order thinking, okay, basically your personality, who you are, okay, your decision making, okay, planning abilities, right, good or bad judgment, okay. This is located in the prefrontal cortex. So this is going to be in front of your motor cortex and your motor association areas, okay. Interesting fact, right, this area, I personally think that it still is developing past adolescence. I personally think that in my 40s, the way I think in my 40s is different than the way I thought in my 30s. Definitely different than the way I thought in my 20s and teens. All right? But we're seeing that this area is still developing, right, through adolescence. Okay? Now, adolescence can go into your early 20s. Okay? It starts with puberty and then moves through to the teens and then into the early 20s there. Okay? So you heard me talk about Broca's area. Remember that was that motor vocalization speech area that I was telling you about, and that's found in the frontal lobe. Well, we got this area called Wernicke. Again, this is another guy that was doing brain mapping. Okay? Wernicke's area is also in the left hemisphere, on the left side of your brain, but this has to do with language comprehension. So basically, right now, as you guys are sitting there listening to me ramble on, okay, you're utilizing your Wernicke's area. You can basically understand the language that I'm communicating to you with, okay? So you might be hearing the words I'm saying. You're understanding my English language somewhat, I hope, right? But you're not completely confused, like, what is this guy saying? Okay, so you're exercising your Wernicke's area. If you were to lesion this area, I could be talking, and you could be hearing me, but you would have no clue as to what I'm saying. Now, you could talk to me, just be like, Dr. Kos, I don't understand what you're saying. Can you repeat that again? What does a cow and ice cream and ginger ale have anything to do with all this? What it would sound like you just would not be able to comprehend. Now, you could still speak to me, because that's a different area. You'd be using your Broca's area. Broca's area is the motor speech area. So you'd be able to vocalize your words, okay? But when I was speaking, this area here, Wernicke's area is more in the parietal area, lobe, I should say. Let me see if I can find. I'm still trying to understand. I know. I thought I had a picture. Here we go. Correct. Yep. So, yep. If you had a lesion to the Wernicke's area, you would not be able to understand what I'm saying because you've lesioned your language comprehension. So it wouldn't make sense to you. But when you started to talk to me, because you're using a different area of your brain, what you're saying, you would understand what you were saying to yourself, right? Because you're thinking it, and I would understand what you're saying, okay? If we look here, right? Here's our left hemisphere, okay? So here's the Broca's area. It's in the frontal lobe here on the left hemisphere, okay? And back here, this is Wernicke's area. This is in the parietal lobe, right? In this area here, if you were to lesion this area, you wouldn't understand what I'm saying to you, okay? Just because it would not make any sense. Okay? Oh, darn. I think I should probably stop. I know. Wait, hold on one second. Did I finish? Oh, perfect. Okay. So, yeah, that's actually a good place to stop. And we'll pick up with autism on Thursday. Okay. So that actually, not too bad. Okay. Guys, let's take a break.